Hey everyone, welcome to this lecture. In this lecture, we're going to talk about object-oriented programming. So, object-oriented programming is a structured approach to coding that helps us organize and reuse code efficiently. Most Python libraries are built using object-oriented programming principles. So, understanding the basics of object-oriented programming will help you to better read, reuse, and modify code within these libraries, as well as develop your own code. In object-oriented programming, so we call this term object as an instance that contains specific data, properties, or attributes specific to that objects, as well as methods or behaviors based on those attributes. So we use a class structure to serve as the generic structure or blueprint for creating objects. Within this class, we define the required attributes and behaviors, and then we can use that class structure to create as many objects as we want. So, for example, consider we have a car class here that defines the generic structure for car objects. And here we are saying that each car object can have properties like color, price, mileage, models, etc. And also have specific methods like how do they start, go backward, go forward, stop, etc. And using this generic structure, we can create car objects. If the first one, we are saying its color is red, the price is 23,000, and then it goes like 1200 kilometer and all of this information. And in the same way, we can create bunch of car objects, and each of them will have unique properties and behaviors while maintaining the consistent information structure. So here I'm showing an example of creating a class called city, and within this city class, we are gonna provide some generic city attributes, including name, region, population, and area size. And using this class structure, we can create bunch of city objects later. How do we do that? So first of all, we will start with specifying that this is a class. So you need to put the term class here, and then you put the name of the class, in our case, which is city. And usually we capitalize the class name. And then you put a colon, and in the second line, you first say def. So this is the same as the normal user-defined function. And then you say init. And this means like we are initializing the class. And then inside the parenthesis, we first write this self. So this self indicates to the object themselves. And then we define our attributes, say name, region, population, area, and we are saying that okay, the for this particular object self, the name would be equivalent to the parameter name, and for this particular object, its region would be equivalent to the parameter region. And later, when we are defining the object, we are going to put specific arguments to these parameters, which would be specific to that object. We also have a method here that's called calculating population density. And here inside the parentheses, I am saying like use all the object specific information. So that's we are calling this self. And then we are saying that calculate the population density for this particular object using its own population information and using its own area information. And eventually this method is going to return the population density. And if you print this class city, it will tell you that this is a class. If you print this method, calculate population density, it will tell you that this is a function. Now we defined our class, we can next instantiate an object, and we can store this object as a variable. So here, what you can do, first of all, put the variable name, like the variable within which we're going to store the object, and then you will put this equal sign, and then calling the class name inside the parenthesis. provide the arguments for the class parameters. So you are putting the city name, region, population, and area. And then if you print this variable, it's going to say that this is an object specific to this class city. You can access specific object attributes. You can do that by putting the object name dot the attribute name. So in our case, mycity.name will return the name of this city. Mycity.region will return the region of this particular object. And it goes on. You can also access the methods associated with this particular object. How we can do this like you can call the object name dot and then the method name, and it will return you the particular output of that method specific to that object. So here we are calculating the population density for this particular mycity object. In the similar way, we can specify a bunch of other variables representing city objects, and using city class, we can specify its attributes and its functions and everything. So now we learned how we can create and instantiate objects and classes. So now we can learn about some theoretical concepts behind the object-oriented programming. The first one we have is the principle of encapsulation. And encapsulation broadly means the act of enclosing something. So through encapsulation, we can restrict direct access to an object's data and modify it only through control mechanism. And in general, with encapsulation, we can create more modular and reusable code. We can protect and secure our data, and we can avoid any unnecessary modifications. So here I'm showing an example. Let's say we have a road class, and that has some generic attributes called length and altitude specific to its road objects. And with encapsulation, we can protect these attributes from unintended modification by restricting direct access to them. So for example, we can put a single or double underscore before the attribute name when we are specifying the attributes, and this will indicate that this attribute is protected and private and only for usage within the class or its subclasses. So here you can see that an example. So I'm defining my class road, and then I am initializing it, its objects, calling the self, and then we are specifying the parameter, length, and altitude. And then we are defining the attributes. We are saying that this object's length attribute will be equivalent to this length parameter, and this object's altitude attribute will be equivalent to this altitude parameter. However, here you can see that I put this single underscores. This indicates that this attribute is protected, and we should not modify this information outside of this class. And so let's create an object, then it will have a better idea of what I meant. So first, we are creating this road object using this road class, and inside the parenthesis, we are providing this information like length 1000 and altitude 50. Now we can access the unprotected attribute as it is. So we can just call it road.length. It's going to return you the information. However, if you try to access the altitude information, you can just put like road.altitude, and it's giving you an error. It says like there's no there's no such parameter or attribute named altitude. But this is something we have defined in the when we were defining the class, right? All right. However, this is more like a convention. It's not strictly enforced. You can still access the attribute information outside of the class and modify it as needed. All you can do is just put that underscore back. So you can put it like road dot underscore altitude, and you are gonna see the altitude information here, you can also modify this attribute. So you can just say road.altitude would be equal to 100. So it will be updated instead of 50, the information will be updated to 100. But like I said, it's more like a convention. So when you see this like underscore sign, it means that we are not supposed to modify this attribute information outside of the class. This might be like in many cases, in many for many functions, this is probably some fixed information that we don't want to change. So it would be the best case scenario if we do not modify it outside of the class. The next one we're going to talk is the principle of inheritance. Uh, So, as the naming suggests, by inheritance, we mean that we will have a meta class, the parent class that will have the generic attributes or methods, and then we'll have some subclass that will inherit those properties. And there are numerous benefits. So, first of all, we can write the code once and reuse as much as we want for the other subclasses. So our code are going to be like less verbose. Also, at the same time, if we want to edit that particular code, we do not need to do it multiple times. We can do it all in the same place and just call that information everywhere. Now, here you can see an example. So, inheritance works best when we have a hierarchy in our classes. Like we can define something as a parent class and define the others as the subclasses. So here I have shown an example of specifying a generic polygon class. And this polygon class will take a geometry attribute and it will calculate area for that method, for that geometry. And then we can create specialized subclasses like a class for the states, a class for counties, cities, and etc. And all of these subclasses can inherit the attribute and method from that generic class, generic polygon class, and then calculate area for the respective administrative boundaries. So here I'm defining the parent class and I am saying that it will take the geometry parameter and the all of its objects will have this geometry attribute that will be equivalent to this geometry parameter. And then uh, this class has a method that can calculate area for that particular geometry. Next, I'm specifying a child class that inherits all attributes from the parent class but do not have any additional attribute. In that case, we can just put this pass term. So it means that our subclass city only inherits all the characteristics or all the properties and methods from our parent class metapolygon, but we are not specifying any additional attribute. However, some subclass can have additional attribute. For example, in this next one, this subclass county, they have additional information called name. And here we can say that, like as we did before, we can just use this define option and then we can initialize the class and inside the parentheses, we can put all the property names as it is. Um, and then we are saying that for all the objects, they will have an attribute called name. And for all the objects, they will inherit the properties from their parent class, which we are referring here using this super function. And we are saying like, okay, this all the objects will inherit properties from their parent class and execute those properties using this geometry parameter. So they're going to calculate the area using this geometry parameter. To show you an example, I'm creating a polygon geometry here using the shapely geometries, and we are just arbitrarily creating some squares. So first one we have for the city geometry, and the next one we have for the county geometry. And next, we are going to create this class object using those geometries as input. And the last one is we're going to print the geometry area. And here you can see that printing the first one, so we are calling the object name city and then asking to execute the calculate method, and it's returning area size 16. And for the next one, we are putting the object name county and asking to calculate the area here. So it's returning 4. And we are also printing the name attribute for this county. All the examples I've shown here, they are only inheriting properties from only one parent class, but there can be multiple parents, and like new subclass can inherit properties and functionalities from one or more parent classes. For the next one, we're going to talk about principle of polymorphism, and this concept allows objects from different classes to respond to the same method call in different ways, and based on their specific implementation, those method calls will vary. And a practical example of polymorphism is when all the subclasses inherit from a common parent class, and then we can override some of those methods to enable specific behaviors. So this will ensure that the class objects behaves appropriately while still being treated as an instance of the parent class. We often call this as method overriding. It's particularly useful for GIS because GIS data has like different spatial data structure, and the method we have may appropriate for one structure, but for other cases we may need to overwrite a little bit of that method. So let's say in the previous example, we are not gonna always have the polygon features. There might be some other features like lines or points, and for which area calculation is not feasible. And in that case, we need to override the method to perform an appropriate operation. So here, in this case, I am again like putting the parent class here, and within the parent class, we can only calculate area for that particular geometry. And then I'm specifying a child class called city, and it's inheriting all the properties of the parent class. Next, I have a subclass called road. So this is a line feature. And that's why we need to modify this calculate method. And how are we going to do that? So we are going to redefine this calculate method, and we are going to say, okay, now using this object geometry, return the length. I have another subclass called building, and I'm going to also redefine the calculate method for this building because it takes only the point geometries. And I'm saying like for this point geometries, only return the x and y coordinates. However, you can see that for all of this subclass, we are still using the calculate method. The method name is still the same. So we can we can still call the calculate method for all of these subclasses and get different output depending on the object characteristics. So for example, here we are creating some arbitrary geometries again, polygon for the city, line string for the road, and point for the building. And then we are creating class objects using these geometries as input. And like I said, we can, like for all of these objects, although they are coming from different subclasses, we can still call this calculate function, and their output would vary depending on their subclass characteristics. So here, for the first one, it's returning an area. For the second one, it's returning a length. And for the last one, it's returning x and y coordinate. Then we're going to talk about principle of abstraction. So this is the last principle we're going to talk about. So with principle of abstraction, we only show the essential features of the class while hiding the internal complexity. And this makes it easier for user to interact with an object without needing to understand any details or any implementation that's going on in the background. And the main goal here is for um, making the code and output more simplified and user friendly so that like the non-technical users can better interact with the um, code and the outputs and only see the necessary information. So for an example here, so let's think about when we created the spatial maps or when you are planning to create a WebGIS interface. Even putting those north signs and scales were very complex. There were like complex algorithm, complex codes going on in the background. However, for like non-technical users, all they want is to interact with the map. Like they may want to zoom or pan, something like that. In this case, we can use abstraction to hide all of those unnecessary complex details and only show the necessary output to make this code more user friendly and in more intuitive. And I'm not gonna show an example of abstraction given it's gonna be very lengthy. Um, but later in the next class when we're gonna put all of this information together um, as with a practical example, you are gonna see what I meant. So that's all I have for today. Thank you so much for listening. If you have any question, please let me know. Thank you.